Hi everyone, my name is Tobilid of BSECE 3A, and today we're going to discuss under the subject ECE 36 Microprocessor and Microcontroller Systems and Design. And we're going to have a comparison between the Arduino board that I have and compare it to the specifications of the original Arduino Uno R3 made in Italy. My Arduino Uno R3 versus the original Arduino Uno R3 made in Italy. Right, so in terms of the appearance, you see that the original has a well-defined PCB silkscreen. In terms of the color, original Arduinos are produced with a teal color, which is a blue-green color. Virtually, all counterfeits still uses the blue color, and this is a very straightforward way of identifying a counterfeit. In terms of its logos and font, the original Arduino uses the same font for all text on the board. The registered mark is next on the logo, and it has a quality print with well-defined letters. While the counterfeit board, which is the one that I have right in the video, it has a trademark symbol next to it. It has an acceptable print, but not well defined, since you can see in my Arduino that some prints are not filled properly. So see that example right there. And lastly, the most noticeable thing on my board is that it uses a variety of different fonts for all the text printed on the board. So you see that. In terms of overall execution, my Arduino Uno R3 is poorly made, saying that some of my components are slopping, compared to the original Arduino Uno R3, which is well made and it looks uniform. Also, the difference in the positive temperature coefficient. Original Arduino Uno R3 made in Italy has a custom golden black with a 501K printed on it, or the Arduino Infinity symbol printed on it. So as for this slide, I only showed you the Arduino Infinity symbol print. On mine, which is a counterfeit, it is also a golden black print, but it's different because it reads 509T. Alright, so now we have identified the differences. Let's discuss and compare its specifications. Right, number 1. Actual microcontroller chip, part number, and packaging. You see, both of these Arduino have the same microcontroller chip, namely the Atmega 328P, which has a total of 28 pins. And in the packaging, the original Arduino Uno R3 comes in a well-made cardboard box, and it is compact, with the top side having a graphic of the board and the bottom side showing the list specifications for the board. But I don't have the bottom side picture of this board for now. My Arduino Uno R3, which is a counterfeit, it came in a cheaper packaging, or a generic packaging, which is the plastic container, and the Arduino itself was inside a plastic anti-static bag when I first had it. Number 2. The actual included USB controller. Now don't be confused. There is actually another microcontroller used to program or communicate with the actual microcontroller, which is the Atmega 328 Pico Power. And yes, it is also the USB controller. You see, both of the Arduino have the same USB microcontroller, namely the Atmega 16U2. Next. Number 3, number of terminals or pin configurations. So in our Arduino, also in the original, they both have 14 digital pins starting from D0 to D3. 6 analog pins starting from A0 to A5, which you can locate here under the analog in. There. 1 reset pins, 3 power pins, namely the 3.3V, 5V, and the voltage in. Out of the 14 digital pins, 6 pins are used for generating PWM pulses of 8-bit resolution. So PWM pins in Arduino Uno are D3, D5, D6, D9, D10, and D11. PWM pins are defined by this symbol. It's called a tilde. We also have the IRF pin, which means input output reference. We also have the reset pin and the RF pin, which means analog reference. Number 4, other components included in the controller. You have capacitors, resistors, transistors, diodes, reset buttons, power jack, type B USB connector, which we connect here, crystal oscillator, which is this one, a microcontroller, pins in the USB microcontroller. Number 5, PCB layout and design. So you see there is a big difference between my Arduino board compared to the original. Let's talk about the color. You see that the back of my Arduino is white on the other half. It has a similar orientation of components placement compared to the original Arduino Uno R3 made in Italy. So they are identical in some ways. The original has a well-defined tracks and it has a mechanical features that has a distinct outline and it scores high in terms of functionality as well as looks. Number 6, PCB quality and quality of soldering. PCB quality is good. There is no welding repair or open circuit repair on both of the microcontroller. The quality of PCB boards are generally judged by appearance. Both of the Arduino board we see on the screen have neat finishes. They are soldered into perfection. The soldering of the original is of course a bit more careful and beautiful. Well, this is to be expected given the price of the original. In dollars, it is about 20 and above. Number 7, memory differences. You're going to have a comparison between the flash memory, static random access memory, and the electrically erasable, programmable, read-only memory. So in flash, we have 32K bytes. In SRAM is 2K bytes. EEPROM is 1K bytes. As well as the microcontroller clock speed. Both of the Arduino, the counterfeit in the original, both have 16 megahertz clock speed because both of these microcontroller uses Atmega 328P. So in conclusion, there is advantages and disadvantages of Arduino clones. Let's talk about price. The price difference might seem a bit suspicious, but you have to consider that the price of manufacturing electronic components in China is very low. It should also be borne in mind that the price of the original Arduino boards is higher because parts of the profit obtained directly are being used to support the community. Disadvantage is that there is a lack of community support. As you saw a while ago, it has worse finishes, which is mine. And so far, I haven't encountered a problem. So maybe with clones, will have technical problems. For example, from time to time, it is not possible to send the compiled code to the board. So the solution is usually to use the reset button or simply reset the Arduino IDE. So that is all for today. Thank you.